morning, I'm Andrew Gawidan, and I'll be presenting to you today a run-through on the progress in the development of cyborg cockroaches. First of all, why cockroaches? The idea of making cyborg cockroaches came from the search for an alternative to the designing and creating of small-scale robots that would be used for navigating hostile environments, for example, the rubble of collapsed buildings. Cockroaches in particular were chosen for their uncanny survivability built into their natural design. Cockroaches can withstand drastic climatic change, get by on little or no food for months, are excellent climbers on rough terrain such as logs and even on smooth surfaces like glass. To top it off, they have a natural tendency to flee upon sensing danger. A robotic system would have to give particular emphasis on the need for precision in terms of control and motion. Cockroaches, on the other hand, have their own natural behavior for exploration, and researchers sought to exploit that. The question then is, how do we exploit that? To be able to direct the cockroach, two of their vital sensory organs are utilized: the antennae, which detect obstacles in its path, and the cerci, a pair of tiny hair-like appendages located on its underbelly which perceive air movements often associated with threats. Wirelessly firing pulses to the cerci spurs the roach into action, and zapping either of the two antennae creates an illusion of an obstacle that induces the roach to turn. Directing is made possible by what is referred to as a backpack. A basic backpack includes a thin circuit board with a microcontroller, a wireless signal transceiver, miniature plugs for connecting stimulation electrodes, and a lithium-ion polymer battery. The electrodes are surgically implanted inside the antennae near the region surrounding the cerci. The backpack itself is attached via magnets that are glued to the insect's back with medical-grade epoxy. A cockroach weighs around 20 grams and is capable of carrying another 5 grams, which is enough for a miniature camera, a microphone, a gas sensor, along with the steering pack itself. The control of the cockroach took a few steps forward with the incorporation of Microsoft's motion-sensing Xbox device, Kinect. It was used to guide the animal on a pre-planned route. The Kinect also gives rise to the opportunity of tracking the cyborg insect and making adjustments in its direction. The Kinect allows the cockroaches to be controlled on autopilot, wherein the roach moves along a digitally plotted route, and the Kinect system monitors its progress and corrects any drifting from the path. Kinect is also able to collect data on how the cockroach responds to the electrical impulses. This will allow researchers to fine-tune the technology and steer the cyber cockroaches more accurately. In search and rescue operations, unfamiliarity with the terrain and environment is a given. We won't have any idea of what it's like inside a collapsed building unless we see it for ourselves. Being able to control the cockroach, we should also be able to track it. The attempt at actual localization involves short-range area transmitters which track when agents meet each other. When they're a few yards of each other, signals are sent to one another and those encounters are recorded. The encounter events are converted into some sort of map of the environment, and a topological aspect comes into place. What's made is far from what we think of when we hear about maps, for example, Google Maps, because the result of this is but a rough sketch of what the environment is like, but it does give us useful information, possibly in pinpointing if someone is trapped, how to get to that location, a rough idea of distance, landmarks, possible entrances and exits, to name a few. Algorithms are still being tested for exploration and mapping simulation environments based on biological models. One particular limitation of cyborg cockroaches were the batteries. Batteries are heavy and need recharging, so Japanese researchers sought to find an alternative. They came up with a fuel cell that generates electricity by using trehalose, a sugar contained in the insect's body fluid. It consists of electrodes, a tank of body fluid, and a needle-like pipe which is inserted into the insect. The inside of the tank is separated by a dialysis membrane. Trehalose is broken down by enzymes to produce glucose. Glucose is then oxidized on the positive electrode side, and oxygen is generated on the negative electrode side, resulting in an oxidation-reduction reaction, creating a simple battery that can power the electronics the insect carries. Prototype fuel cells have been made via 3D printing, and it was able to generate 50.2 microwatts of power. Considering everything that has already been mentioned, we can see that there are very diverse possibilities in which cyborg cockroaches can be utilized. One would be in environmental monitoring, in particular the measurement of chemicals and pollutants, even under radiation. Cockroaches in the Philippines have been known to mutate to the environments around them, notably would be the sewage system. These cockroaches would be more suitable for the measurement of various chemicals and pollutants. Cyborg cockroaches are also playing a crucial role in robotic studies. The functions and structures of cockroaches are being mimicked to develop high-performing micro-robots. Cyril Grison, taking the same innovation class, discusses how smart paper makes traceable money possible. We take a page from his book and incorporate what is known as LEAP, laser-enabled advanced packaging technology, a process which allows the high-volume placement and interconnection of various types of ultra-thin, active, and passive microchips. To learn more on this, I would recommend taking a look at his presentation. The LEAP technology will basically allow the minimization of size of components attached to the cockroach, allowing it to look more natural, opening up the possibility of use in spying, while also improving the rescue operations potential of cyborg cockroaches by allowing more flexibility in the functions and devices that can be incorporated. In theory, we can now have an army of robo-roach henchmen to do what humans don't want to do and to go where humans can. The patent I chose is by Dr. Alper Bosgert of the Electrical and Computer Engineering Department of North Carolina State University, one of those who presented the idea of cyborg cockroaches in various conferences. They patented the method of surgically implanting microelectromechanical systems, or MEMS, in arthropods.